Alright, welcome back to Symmetry analysis, bilateral symmetry. I want us to continue from where we left off. Now we want to start practically computing the symmetry analysis now. First one I want us to try first is object symmetry using the Heatmaps data we collected. So let's try with that first. Right. So before we go further, I want to quickly show us what are the requirements, because we need some files that are needed to compute this analysis. Don't forget, we have digitized our face twice. If you open this folder here, you see that we have our face data. I call it face data. Okay, let's open it and see. What we have used before. Okay, a double twice of that one we have before. So and what we have there. So that is number one. We need. Don't forget that is a double two replicates. Don't forget that. So the second thing we need is our individual data. So let's open this. Let's open it. Just open it there so that it can be easier. Now look at it. Look at this now. This is very important. I want you to look at it critically. The same data we have here, this one is no problem. You can remove this if you don't want. So this is just to show this line. So that's why I don't have anything here. Okay, I will not read this line. Okay, so we only read it from here. All right. So this is what we need. So this is each of the ID of the specimen. All right. So but this ID is number total. Yeah, we are 16 numbers. Don't forget. So we have to copy this from here now. We have duplicate here also. From here now, we copy to 60. Yeah, so this is 60. So we start afresh again. We copy now. We paste here so that it becomes twice. See, this 120 now. All right, this 120. It means we duplicate it here now. We copy this. We paste it down to make it 120. All right. So I mean we have twice of this one here. This is two duplicate as well. All right. So this is called individual data. That is how our TPS file is structured. Don't forget that. That is how it is structured. So we have to follow the same pattern. All right. So that is the second thing we need. The third thing we need also is our pair data. So in this pair data, I explained this previously. If you open here, you remember last time we were discussing this. I said that it must go in a proper alignment. All right, look at this 37 now. So we have this factor 1, factor 2 now. This one or 1, 2, whatever I want to call it. So don't mind the one. This was you can give any heading here. Don't worry about that. You can give any heading. It can be H1, H2. Doesn't matter. So here we have 37. Don't forget we have here also what 37. So look at it here 37. We have 1, 6, we have 2, 5, we have 4, 8, we have 20, 22, we have 12, 13, we have 16, 17, we have 19, 21. You can see these are the pair data now. Same thing we have here, all right? So it can come. It doesn't mean that it must be from up to down. Must be sequential like that. You know, it can be from down to up. It doesn't matter. Okay, it can be from middle up down. So just make sure that what you have here is in line with what is here. That's what is important. Okay, so you can change the order here. Okay, the number 9 can go to number 2. But line 2 can go to line 3 can go to line 5. Doesn't matter. Present as much as the pair is accurate. Whether is the pair, all right? So this is second data we need now. So let's skip this one. The third file we need is called rep data. Let's call replicate. Now this is where the challenge is now. You need to understand this. This replicate now. Look at the way it is structured. It's different from our individual data. Even though it has the same pattern. I mean the same numbers, the same observations, but the structure is not the same. The pattern is not the same. Look at it now. We have AF01, AF01, AF02, AF02. You see that? Not like the individual that we copy and paste again. No, it's just 1, 1, 2, 2, 3, 3 like that, because we have 2 duplicates. So this is Harrow method. Don't forget, this is Harrow method of doing things. So if you do it anyhow, you have wrong result. Sincerely speaking, your result will not be accurate. All right, even though you may run, but you have a wrong result. So here you have to follow accurately. For me, if under normal research condition, I will not use this kind of a data set, this kind of ID. I prefer to use numbers ID, maybe 1, 2, 3, or 1001, 1002, because if you have, for example, 3 duplicates, for example, how do you generate this? It will take it some time. Understand? It takes some time to generate this in Excel. All right. If you have 3 duplicates, because we have 2, it's easier for me to enter one by one, enter this, enter this, enter this. Okay. But if you have 3 duplicates, it won't be easy to enter. In fact, you can make mistakes. You can make a mistake. So, but if you have a number, you can compute the number automatically. For example, then if I have maybe 1, 1, 1, 1. So this is 3 duplicates now, for example, now. For numbers, if I use numbers instead of using strings here, so I can have 1, 1, 1, 2, 2, 2, 3, 3, 3, 4, 4, 4 automatically. For example, now how do I do that? I can do that in Excel. So look at this now. If this one now, I can start here. So what do I do? I just say equals to. All right. This line is D. Just say D. D what? Start from D2. D2. Right, plus 1. So press enter. That's all. If you give me 2, then you click on 2, drag down, autofill. You can see you have what? 1, 1, 1, 2, 2, 2, 3, 3, 3, 4, 4, 4. For this 2 duplicate now, just say, okay, you have yourself 1, 1. Example, okay, let me say we have 1, 1, 0, 1. Okay, 1, 0, 1, 1, 0, 2, 1, 0, 1. Okay, for 2 duplicates now. Okay, so this is my ID, for example, now. I want this ID to follow this pattern as well. All right. So I just do what do I do? Instead of using one by one, I have 2 duplicates. I just click here. I say equals to. All right. This E. Say E. So what is first one? E2 plus 1. Press enter. Can see give me this. So when you drag this one down now, you can see you have 101, 102, 102. 103, 103, 104, 104, 105, 105. You can see you have them like that. If you have 100, it will flow. Same with 3 duplicates. So you can do that in Excel very fast. If you are dealing with numbers, but if you are dealing with strings, it's very difficult. You have to do it manually. All right. So that's advantage. But never mind. At least when you play around for some times, you have a better understanding. So don't forget this. Now it is very important. This is your 1, 1, 2, 2, 3, 2, 2, 3, 3. Because you have what? 2 duplicates. So that this is what we have. We need rather. So let's go and now compute our analysis now that we have our data ready. Let's go and compute now. All right. We have everything we have is ready. So let's start by first computing our. Run this again. Let's run this again and see. All right. So let's now landmark. Let's say start from landmark. LM equals to. Let's read our landmark first. Our landmark, let's read land. What's the name of our file again? Face what? Face data. Thank you. All right, face data dot cps. Okay. Then comma space id equals to id. All right, so let's run this line. Or let me just copy type and run together. GPA equals to GPA equals to GPA. So what do you have? We have LM, comma. I don't want to see the result of printing. Let me just print for the result of false. Right. So let me. Let's say GPA. Is that possible? Okay, let's assign GPA to coordinates now. Let's just make it like this. GPA coordinate let's say we want to see continuous equals to, let's just create that variable now, don't worry. Equals to, let's call it GPA dollar coordinate now. So let's run this. Alright, so this one they are running now. Let's move. Just so let's continue now. Let's call our SF files CSV file. Don't forget those files we created. We set them as CSV. Don't forget, as CSV. So you can call them in now. You can call them in data. Okay, equals to read CSV. What's the name of the data now? In the individual data now. Individual data .csv. Alright. Same thing with pair data. Right. CSV file. So we have pair underscore data .csv. Alright, same thing with rep data. We have CSV. What's the name? The name is rep underscore data .csv. Let's run this now. Alright, so let's continue. Alright, so let's now assign a variable to our individual data and rep data, because they are just a single file. Don't forget, they are just single file, single column rather, single column. So individual equals to int underscore data $x. So also we have our rep equals to we have a rep data, rep underscore data $x, right? So let's run that. We don't need for pair because that pair is having two columns. Don't forget that. So we just call it straight. So let's create GDF now. GDF, right? Let's create a model for it, a geomorph data frame. So our shape, this has this particular function as a shape parameter. So shape equals to what? Don't forget our GPA what? GPA underscore coordinate. So we have individual equals to individual. That's individual parameter. We have a replicate also. Replicate equals to rep. Don't forget that's our variable. Alright. So let's run this line. That's correct. So don't forget we are passing that parameter inside here. So because it has a parameter called shape, a parameter called individual, and replicate. So we have to assign that our coordinate to our shape. That's our shape now. Our individual to our individual. Our replicate that we created here now. We assign to this particular parameter. So let's move on. Let's now call what they call it now. Let's call it new symmetry. Okay. Let's just give it a name. Symmetry equals to bilateral. Okay, symmetry. Alright, A equals to shape. As a shape, then individual equals to individual. Right? Alright, we have rep equals to rep. Alright, we have object of symmetry equals to true. Alright, we have landmark the PS. What's our landmark the PS? So just apply a PS. That's for data. Don't forget that. That's what we have here. Is that not correct? You can break this line so that you can see what we are doing. Let's break this line so that you can see what we are doing. Alright, let's break it. We have not finished the data. Our data is what? GDF. That's what we created here now. Pass it here. So let's run this line first and see. Oh, I don't want this progress, but it's okay. Let's just continue. So now we want to plot our result. Want to present our result now. So this is just a summary. New symmetry. The one we just created just now. Sim. What we created now. Forget this one we created just now. So let's run it and see the result. See the result here now. Something is missing. Anything missing? Yeah, something is missing. Something is missing here. What is that? Let me check. Cannot find our replicate here. Cannot find our replicate. Let's see. Duplicate equals to rep. All right. This shape, we have shape. Individual equals to individual. It's correct. Rep equals to rep. Object symmetry equals to true. True. Let's see. This is true. Let's add this for iteration. This iteration equals to 999, and let's say we want to add this RRP equals to true. True. Let's forget about progress. Print dot progress equals to false. Right, so I'm just looking at what is missing. Rep data correct. Rep data $x correct. You will run this. I think run this. Let's now run again. Let's run this again. See first, that one is running. Let's run this again. Something is missing. Coming. You have missed something is missing here. Something is missing. Something. Let me check. Let me see if I can. Let me put ANOVA first. Let me put ANOVA only. Let me see if I'm correct. ANOVA. What's the name of this? Just trying to check what is missing. Okay, let's say new dot. What's the name of our symmetry? Is new dot symmetry, right? New dot symmetry. Okay. Dollar shape dot ANOVA. So let me print this. If I'm correct, I will know. Let me see now. Let's run this. Okay. No, nothing is missing. Nothing is missing. Everything is accurate. Sorry for that. Nothing is missing. So I was just testing using summary to test the analysis. So nothing is missing. Everything is accurate. So now look at this. Now we have individual data. All right. We have a side. This individual now. This is called symmetry. Now you can see that it's symmetrical. Okay, that is symmetric. It's significant. We have side. Side is called DA. Don't forget DA. Directional symmetry. All right. So it's significant. You can see FA. Okay. FA is inside by this is individual by side. is called FA. So it's not significant at all. All right, it's not significant. All right, so you can see the error, the port error is called 0.003. Okay, so you can see that this is our accurate result. So we have to keep this result now. It's very, very important. Keep it for comparison. When we use other algorithm or other program, we have to keep it for comparison. So let's keep the result. Okay, I will just keep it. Okay, for further analysis, then you can compare them to see how accurate they are. But the challenge you can have here in this Haru is that how to visualize your data is not sophisticated here under Haru. Let's see the plot now. Let's see the plot. Dot symmetry. Okay, comma. That's our variable. Warp grid equals to true. Then mesh equals to false. For 3D, you say mesh equals to true. For 3D, this is 2D, so that's why you say mesh is equal to false. Start to understand that the same formula goes for 3D, just to change some parameters. So let's run this and see the result. What we have here. So let's zoom it and see what we have there. So this is a shape symmetry now. This is component symmetry component left, asymmetry right. All right. The same thing, mean directional symmetry. This is mean. So this one is mean directional. This directional symmetry now. This is fluctuating now. Asymmetry. So look at it now. So it's not that beautiful. To me, I don't like the kind of a chart diagram. So I prefer other two to generate my visualization, to plot my the chart out instead of using R for that. So in R is good for charts, but when it comes to symmetry, it's not beautiful, it's not sophisticated in that area. So it needs some improvement. But the coding wise, it can give you good results. So that is no single program is perfect. Understand? They have their merit and demerit. So when you walk around them, you know this one is better in this area, this one is better in this area. So that is that for today. So let us understand this. Just follow what you have done so far. We have not done much. You can see it's very, very easy to follow approach. Just understand the concept. Just follow the pattern. What we need, what are the requirements? Put them there and put the code there, and supply the data, and you run your analysis. You get your result, and come back to continue from where we left off. Thank you. I will see you in the next session.